Hello and welcome to the first tutorial of 2025, and today's topic is references. The overall learning outcome for today's session is going to be understanding the difference between soft and hard references, and then how we can apply this to the correct communication method to your projects and overall games. And by what I mean in terms of communication methods is how we're communicating with objects and assets within our game. Now, when we're referencing aspects in our game, it's a core concept of overall games development, and we have a variety of ways in Unreal in how we can reference assets. There's two predominant methods, which are hard and soft. And a reference asset is by extension loaded in memory. So whenever we're calling something, we are loading that into memory. And this is a direct relation to when we cast or when we're calling something. Obviously, it needs to be into memory for us to be able to actually get that information. So we have a hard reference where object A equals object B. Object B is loaded into memory when object A is loaded. It's a direct link. So if you've got a character which has loads of hard references of assets, all those assets are loaded in when that character is loaded in. And this is often something I find most problematic with student projects. So I see students, a lot of time when I see performance issues, the first protocol I always check is going to be your blueprints and your hard references. Yeah, after all, they're fast to access, but obviously they can quickly bog down your project. We then have soft references. So object A points to object B. It's an indirect reference. It's far slower, but it does mean we're not loading those assets in when we're compiling and we're loading into the game as such. We're moving around. We're sort of just holding a location to that, and then when we need to, we can load it. Which obviously, performance-wise, is really useful. We don't want everything loaded in game. But one of the key things I struggled with when I first switched to Unreal, and when I teach them, one of the things I think a lot of students sometimes struggle with, and depending on if you want to know everything, there's a key question we have to ask ourselves: what is a reference? Before we delve into what a reference is, let's just take a step back. And actually, let's get into some nitty-gritty back-end stuff. So there is a terminology issue here. So we often hear the word references or reference, hard and soft, and they float about interchangeably. But if you're aware of C++, a reference might actually mean something completely different to you. And this catches me out of sync when I have to sort of check what I'm talking about sometimes, what other people are talking about, because it can get a little bit confusing. So if we look into C++, obviously, which is what Unreal is predominantly built on, and it's called coding language, a reference is a C++ term, which is essentially it's a reference variable is a reference to an existing variable. It's an alias, it's a nickname. So I've got some example code there. So we have string food equals kebab, which is obviously the value of the variable, and then we have string and meal. Now, and basically tells the compiler we're denoting a reference, and that variable is holding the address of food. So we can then use food and meal to mean the same thing. It's going to be really, really useful, and is often used when you're doing return values, etc. Now, in C++, we also have a pointer. Now, a pointer is a variable which stores a memory address as its value. Obviously, this is something we use quite a bit in C++. It's fast, it's highly efficient, and if you've ever declared a pointer in the wrong place or not cleared it and crashed your engine, you know how painful they can be to debug as well. Now, a reference and a pointer are very, very similar. References are less powerful, however, because one of the key things is you can't reassign a reference once it's declared and assigned a value. With a pointer, obviously, we can. There are similarities and there are some differences. So from here, let's go back to the original question. What is a reference? Now, if you were to look on the Unreal documentation, they now actually mention they are pointers, or high-level pointers, managed pointers. I couldn't find anything before Unreal 5 which labelled them as managed pointers, but the Unreal documentation now labels them as managed pointers. But I also reached out to someone who is probably one of the biggest go-to for code, and you should check out his website. I'll link it in the video and the documentation. But I spoke to Tom Lumen, and I asked him how would he describe what a reference is. Would he describe them as a high-level pointer, a managed pointer as such? And this is what he had to say. Good question. I've heard them called managed versus unmanaged pointers too. I was going to call them smart pointers, but that's reserved for non-UObject pointers. Essentially, soft object pointers and weak object pointers are wrappers. Yeah, so depending on your audience, calling them managed pointers might be a more clear job. So we go back to the original statement. What is a reference? Soft and hard references, whenever we talk about this, they are managed pointers or high-level pointers. Now we've established what a reference is. Obviously, it's a high-level pointer. It's holding an asset, a reference value in. Let's dive into Engine. But just before that, blueprints and references. Now, as I've taught students, as I've seen them use Unreal and guided them through the process, obviously blueprints and casting is the most common approach where a reference is created, certainly when we talk about blueprints. Now, if you trawl through the Unreal forums, if you look on the online, there's all sorts of videos on casting and blueprints. Casting's bad, casting's good. Don't cast. And it's quite a bit of muddy water. Casting is a common approach to communicate between objects and assets. It's totally fine to cast. It's just understanding when to use it. So there are issues with casting. When we cast a BP, we make dependencies. Dependencies need to be loaded before the BPs, and they stay loaded. We create a hard reference. The great example is the example I did before. If you have a character and he's loading in all sorts of functionality or components or whatever, he potentially is loading in various other items which are going to cost memory. Now, I'm simply in an engine. All I've done is created a simple third-person project if it wants to load. Okay, third-person template, nothing special, nothing fancy, and we've got our little character who can move, jump around. Now, if I was to find my third-person character, wherever you may be, here we go. If I right-click, I can go to this thing called size map, and this shows me everything that this blueprint is loading in memory. Okay, and obviously there's a fair bit here. 209 megs probably isn't the worst I've seen. I've downloaded a template before now where the character has been almost a couple of gig in references that it's using, which again, I'm not saying it's bad, I'm not saying it's good. It's obviously project dependent, but that's a lot of memory to be using. So we can see every part of here that we're loading in. We have also the reference viewer where we can see all our references to this item, which can be really, really useful when we're tracking down dependencies. So obviously we can see here my example blueprint. Now all this is a base actor blueprint that I've added a static mesh to and just put a simple box purely for visual aspects. Now, if we go here and let's delete you, I have on begin play, I get my player character, I cast, I check if it's valid. Now, this is creating a hard reference. I mean, if I was to promote this to a variable, BP third person, BP the THP ref. This would be a hard reference because this is always going to be loaded in memory when this asset's loaded. You know, so if I was to do, if we go to my blueprints here and we go to audit asset, wrong button, size map, we can see everything loaded, and it's loading everything to do with the third person character because it's a hard reference. So this is something that catches people off guard really well often, because you're loading that object and all their dependencies. So as soon as that's loaded in memory, if that object has dependencies it needs to load in memory, they also get loaded in. And you can see how quickly, if you don't manage these, you can waste a lot of memory and tank your performance very quickly. Now, we can obviously use soft references. So if we look down here, we have this little color code here. Now, soft reference is my example name, and it's a different color, and it's a soft reference to, if we go to the particles, actually no, it's blueprints, the soft reference to one of these. Now, to do that, all I've done is let's find a blueprint, example 2, and obviously if I search an object, so BP smoke, over goes sky, I've got object reference, which is what most people automatically default to. I've got class reference, and then I've got soft object reference, and there we go. I have my soft reference that I can then call when I need to. Now that's a quick showcase in blueprints, but let's take a look in C++. So I just open Rider up, and what I've done here is I've created 2 examples. I've got my uStatic mesh, my pointer called hard reference mesh, and then here I have tsoft object pointer soft mesh. Now, it's important to be aware that with Unreal 5, the process of pointers has changed. So you would normally, nowadays, instead of doing uStatic mesh asterisks, you would normally, if we just get rid of you would normally do object pointer, uStatic mesh, hard reference mesh instead. And this is the common approach now for Unreal 5, and the important thing to remember is this puts a wrapper around the object. So if I just bring this slide over, if we go back to what Tom mentions here, also good to point out the UE5, the standard is TObject pointer, and obviously our asset, which replaces raw pointers for users' handlers. This is a similar job for others mentioned. It gives more control of the memory, is cleared and loaded, and handles garbage collection much better. This is obviously a much more common approach, and the approach they want you to take with UE5. So I would always take that approach nowadays. So if we just look at the, so I've changed my variable. And all I've done here is I'm using the constructed, loading a chair. Obviously, because it's a pointer, check that it is correct. If it's not successful, it's not going to crash the engine, because if this wasn't there, I would crash. And this is going to load that chair into memory. And obviously, here's an example of the soft mesh using a soft pointer. So T-soft subject pointer is very useful and is obviously what we need to use when we're using soft pointers in C++. Just a caveat, this is certainly a new area for me, one I'm delving further into. So hopefully we'll see more C++ stuff soon, but it's something I'm still wrapping my head around. It's been a few years since I've done any proper C++ programming. Now, you've got to cast, you've got to, obviously, if you want to make any sort of interactive gameplay, you have to talk to other components and other assets, and as a result, casting, creating references, it's something you can't avoid. But knowing when, okay, I need to have something loaded permanently, or I can just hold the location to something and load it when I need it, is really, really key. And understanding that principle and the tools available to you, sometimes I think people cast because they're comfortable with it. It's not always the appropriate way. Sometimes event dispatchers are really, really useful. I really like blueprint interfaces personally. There's loads of different ways we can handle situations. Even casting to the base class, is perfectly acceptable sometimes instead of casting to a particular blueprint. So, there was a presentation during the last Unreal Fest by Ari. I hope I pronounced that correctly. I apologise if I haven't. Of casting is bad. That was the myth. Casting is bad. And he produced this diagram for the presentation. I'll link it in the video. And this is something I use when I'm not too sure if I should be casting or when I'm checking my code. Because when I'm prototyping, my code is dirty, and I think that's perfectly fine. When you're prototyping, testing code is going to be not the most efficient. But that is why you refactor code. That's why you go through it. You have code checks when you work on projects, etc. And code gets refactored to be optimized. You don't expect everyone to do optimal code first time round. It's things get better with experience, but nothing is perfect. But I find myself sometimes looking at this diagram. Okay, I need to accomplish this. This is how I'm doing it. Do I need to cast? And this diagram has it all. Obviously, we've got our reference here. Do we need to get a function from it? No. Do we need to check the type? No, we probably don't need a cast. In which case, okay, blueprint interfaces, event dispatchers are really, really useful. Obviously here, do we need to call the function? Is the function declared in C++? No. Is the BP always expected to be loaded? It's fine just to cast. If not, defining the property function in C++ and overriding in BP is, the way to go. It's just a really good way to sort of ground yourself with what decision you should make. And as he mentions at the end, myth is busted, casting is perfectly fine. So if we go back to the very start, obviously look at the learning outcome, understand the difference between soft and hard references, and be able to apply the correct communication approach to your games. Hopefully you now understand the difference between soft and hard references and when to use them, and some approaches you may want to take. And obviously the diagram is a really useful approach. I will link additional resources at the bottom of the video, some obviously epic content in terms of event dispatchers, blueprint interfaces. I'll also link Ari's video, and also Tom Lumen's site is really, really good if you are certainly going down the C++ route. Anyway, thank you very much. I hope you have a wonderful evening, day, wherever you are, and I'll catch you soon. Thank you very much. Bye-bye.